I will try to discuss a little bit the landscape and to try to explain the different modalities. We first start with the camera. As for the camera, it is a passive sensing modality, meaning that the signal is based on sunlight which is reflected by the object, or signal that is coming from the headlamps and reflected from the object. So the performance are heavily dependent on the ambient light conditions. Comparing that to a LiDAR, it's a different scenario because LiDAR is an active sensing modality. The signal is based on the laser light, which is reflected by the object. The detection is also based and relies on the sensor sensitivity, on the system design, and it actually provides accurate range and direction. If we are thinking about FMCW LiDARs, they also provide, on top of accurate range and direction, they provide also direct velocity information. Generally speaking, the performance are highly dependent on the illumination wavelengths. We used to separate between two major spectral regimes. One is the surrounding of 900 nanometer wavelengths, where we have limited detection capability, mostly due to the eye safety considerations, meaning that the power, the energy of the laser is limited due to eye safety, which in turn is limiting the signal that we can achieve. On the other hand, we have 1500 nanometer, the shortwave infrared or the telecom regime. This is eye-safe spectral regime. So in terms of signal, we can get much higher signal. However, on the other hand, it is expensive because there is no CMOS sensor which can accommodate to this wavelength regime. Thinking about imaging radar, it's active modality. It is based on RF illumination rather than standard light. It's RF. And again, reflected signals are highly dependent on the object materials and its ability to reflect or absorb the RF frequencies. When we say RF frequencies, we're typically discussing range somewhere between 20 gigahertz and 77 gigahertz. For example, metal objects are highly reflective, which is in general good. Sometimes it's actually too much because high reflection may saturate the scene. On the other hand, where we are talking about non-metallic objects, some of these are sometimes almost undetectable due to the very low reflectance. In general, we can say that the detection provides direction, range, and velocity. Then we come to CDAR. CDAR is the platform of TRI-eye, and it is based on active illumination in the SWIR regime. CDAR stands for Spectrum Enhanced Detection and Ranging. It is again active modality. The signal is based on a laser, which is reflected by the object. It is based on an eye-safe SWIR illumination, and that's why we can have high power illumination, and obviously we can get much better signal. It operates at a specific SWIR wavelength where the SNR is optimized. So we have optimization of signal-to-noise ratio even at adverse weather condition. And the reflected signals are generally less dependent on environmental conditions and on the details of the scene.